22nd question. The angle measures of an octagon are in arithmetic sequence. What is the sum of its angles? What is the sum of its smallest and largest angles? If the difference between the smallest and largest angles is 70 degree, what is the measure of smallest angle? Will any of the angles of this octagon be right angle? Why? The sum of the angles of an n-sided polygon is n minus 2 into 180 degree. Here number of sides is 8. So it can be written as 8 minus 2 into 180. That is 6 into 180. And that is equal to 1080 degree. Therefore, the sum of the angles of an octagon is 1080 degree. Now we have to find sum of its smallest and largest angles. That is the first term plus last term. That is first term plus eighth term. Now we know first term plus eighth term equal to second term plus seventh term. And that is equal to third term plus sixth term. And that is equal to fourth term plus fifth term. Look at the positions. Whenever the position sum is 9, the sum of the terms are also equal. Now here, fourth term and fifth term are the two middle terms. Number of terms is 8. When we divide sum of the terms by half the number of terms, we get sum of two middle terms. That is, when we divide 1080 by 4, we get sum of the middle two terms, that is equal to 270. And therefore, first term plus last term is also 270. That means, sum of the smallest and largest angles equal to 270. So here we got first term plus last term equal to 270. And given that the difference between the smallest and largest is 70. That is 8th term minus first term equal to 7. So we got two equations. Let us subtract the second equation from the first one. x8 minus x8 is 0. x1 minus x1 is 2x1. 270 minus 70 equal to 200. So we get 2x1 equal to 200. That is x1 equal to 100. That is, the smallest angle is 100 degrees. Now the last question, will any of the angles of this octagon be right angle? Why? Here we got the smallest angle is 100 degree. 90 degree is still smaller. So it cannot be an angle of this octagon. 23rd question. In the figure, AB is the diameter and CD is a chord perpendicular to AB. P is the point of intersection of AB and CD. PA equal to 4 cm, PB equal to 2 cm. What is the length of PD? Draw an equilateral triangle of perimeter 6 root 8 cm. Given that AB is a diameter and CD is perpendicular to AB. Also given that PA equal to 4 cm and PB equal to 2 cm. We have to find the length of PD. We know PA into PB equal to PD square. Therefore, 4 into 2 equal to PD square. That is PD square equal to 8. Therefore, PD equal to root 8 cm. Now we have to draw an equilateral triangle with perimeter 6 root 8 cm. Here we got PD equal to root 8 cm. Therefore, PC also equal to root 8 cm. Therefore, CD equal to root 8 plus root 8, that is 2 root 8 cm. So we can draw an equilateral triangle with perimeter 6 root 8 cm by taking CD as one of its sides. We have to draw an equilateral triangle with perimeter 6 root 8 centimeters. Let us first draw a line of length 6 cm. Now let us divide that into 4 and 2 centimeters. That is PA equal to 4 and PB equal to 2. Now let us find out the midpoint of this line. For that, take the compass and put it at one end. Take more than half of the line in the compass and draw arcs on both sides. Put the compass at the other end. Take the same radius and again draw arcs on both sides. Mark the points of intersections and join them. This is the perpendicular bisector of the given line and it passes through the midpoint. Put the compass at the midpoint of the line. Take this much radius and draw a circle. Now put the protractor at the end of 4 cm line, that is at P, and draw a line by taking 90 degree to meet the circle. Now the length from this point to this point is root 8 centimeters. Since this length is root 8, this is also root 8. So let us extend it to meet the circle again. So we got a red line now. The length of that line is 2 root 8 centimeters. We can draw an equilateral triangle by taking this length as the side. So take that length in the compass and draw an arc. Now put the compass at the other end without changing the radius. Again draw an arc. Mark the point of intersection and join to this point and again join to this point. So we got a triangle now. It's an equilateral triangle with perimeter 6 root 8 centimeters. 24th question. The algebraic expression of the sum of terms of an arithmetic sequence is n square plus 8n. The sum of continuous terms starting from the first of the sequence is found to be 240. Write a second degree equation based on this statement. The sum of how many terms is 240? Let sum of n terms be 240. Then we can say n square plus 8n equal to 240. Now we have to find the number of terms. Let us use completing square method. Look at the coefficient of n, that is 8, half it, we will get 4, square it, we will get 16, add 16 on both sides. So we get n square plus 8n plus 16 equal to 240 plus 16. On the left side it is a perfect square, that is n plus 4 all square, and on the right side it is 256. Now let us find square root on both sides. So we get n plus 4 equal to plus or minus 16. So this can be divided into two equations, n plus 4 equal to 16 or n plus 4 equal to minus 16. From the first one we can say n equal to 16 minus 4, and from the second one n equal to minus 16 minus 4. From the first one we can say n equal to 12, and from the second one it is n equal to minus 20. Number of terms cannot be negative, So sum of 12 terms of the sequence is 240. 25th problem. In the figure, O is the center of the circle and ABCD are points on it. Write the measures of the following angles: angle ACD, angle CBD, angle BCD, angle BAC, and angle DBC. Let us find angle ACD. Look at the figure. Angle ACB and angle ADB are in the same arc, so they are equal. Therefore, angle ACB equal to 40 degree. Now let us find angle CBD. Look at the figure. Angle CBD and angle CAD are equal. Therefore, angle CBD equal to 43 degree. Now let us find angle BCD. With the figure, this is angle BCD. And from the figure, angle BCD equal to angle ACB plus angle ACD. Now angle ACD equal to angle ABD. Therefore, we can write it as angle ACB plus angle ABD. Now angle ACB equal to 40 degree and angle ABD equal to 60 degree. So that is equal to 40 plus 60, or angle BCD equal to 100 degrees. Now we have to find angle BAC. Let us first find angle BAD or angle DAD. That is equal to 180 minus angle BCD, or that is equal to 180 minus 100, or angle DAB equal to 80 degree. Now angle BAC equal to 80 minus, this total is 80 degree. From that we have to subtract this 43. So 80 minus 43, or that is equal to 37 degrees. Now let us find angle DPC. For that, let us first find angle BDC. Angle BDC equal to angle BAC, that is equal to 37 degree. So we got two angles in the triangle DPC. So in order to find the angle DPC, let us subtract the sum of 37 and 60 from the total 180. So that is equal to 180 minus 97 degree, or that is equal to 83 degrees. 26th problem. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. Write the next two lines in this pattern. Write the first and last numbers of the 10th line of the pattern. Find the sum of the numbers of the first 10 lines. Here, the natural numbers are written in order. In the first line, there is only one natural number, the first natural number. And the second line, there are two natural numbers. In the third line, there are three natural numbers. And in the fourth line, there are four natural numbers. So, in the next line, there should be 5 natural numbers that comes after this. That is 11, 12, 13, 14, 15. And in the next line, there are 6 natural numbers continuing like this: 16, 17, 18, 19, 20, and 21. Now we have to write the first and last numbers of 10th line of this pattern. We have seen that in the first line there is only one number, in the second line there are two numbers, and in the third line there are three numbers. Like that, in the 9th line there will be 9 numbers, and the natural numbers are written in order starting from 1. So the total number of numbers up to the ninth line equal to 1 plus 2 plus 3 plus up to 9, and that is equal to 9 into 10 by 2, and that is equal to 45. That means the total number of numbers up to the ninth line is 45, and the last number in the ninth line is also 45. So the first number in the 10th line is 46, and we know there are 10 numbers in the 10th line, and therefore the last number in the 10th line is 55. Now we have to find the sum of numbers of the first 10 lines. Numbers in the first 10 lines means 1, 2, 3, etc. up to 55. That is the sum of first 55 natural numbers, and that is equal to 55 into 56 by 2, or that is equal to 55 into 28, that is equal to 1540. 27th problem. In the figure, the chords A, B and C, D are extended to meet at P. Write one pair of equal angles. Prove that PA into PB equal to PC into PD. Let us look at the figure. We have to write one pair of equal angles. Angle B equal to angle D because they are in the same arc. Similarly, angle A and angle C are also equal. Since they are equal, angle PAD and angle PCB are also equal. Now we have to prove that PA into PB equal to PC into PD. Let us consider the triangles triangle PBC and triangle PAD. In these triangles, angle B equal to angle D. And again, angle P is common for both the triangles. Since two angles of triangle PBC are equal to two triangles of triangle PAD, the triangles are similar. When the triangles are similar, the sides are proportional. Therefore, PA by PC equal to PD by PB. Now cross multiplying, we will get PA into PB equal to PC into PD. 28th question. 301, 308, 315, etc. is an arithmetic sequence. Write the remainder when the terms of the sequence are divided by 7. Find the sum of all natural numbers between 300 and 500 that leave remainder 2 on division by 7. What is the sum of all natural numbers between 300 and 500 that leave remainder 3 on division by 7? Here the sequence is 301, 308, 315, etc. Let us divide the first term 301 by 7, and we can see the remainder is 0. Now take the second term 308. Again, when we divide it by 7, the remainder is 0. Now take the third term 315. When we divide it by 7, the remainder is 0. So we can say the remainder when the terms of the sequence are divided by 7 is 0. Now we have to find sum of natural numbers between 300 and 500 that leave remainder 2 on division by 7. When we divide 301 by 7, the remainder is 0. To get remainder 2 here, we have to add 2 to this. That is, the first term of the sequence is 303. Now to find the last term, let us divide 500 by 7, and the remainder is 3. To make it 2, we have to subtract 1 from 500. So the last term of the sequence is 499. This is the sequence of numbers which leave remainder 2 on division by 7. Therefore, the common difference is 7. Therefore, the sequence is 303, 310, 317, etc. 499. Let 499 be the nth term. Then dn plus f minus d equal to 499. d is 7 and f is 303. So, 7n plus 303 minus 7 equal to 499. Now 303 minus 7 is 296. So 7n plus 296 equal to 499. Taking 296 on the other side, 7n equal to 499 minus 296, and that is equal to 203. Now to find n, take 7 on the other side, so n equal to 203 by 7, and that is equal to 29. That means there are 29 terms in this sequence. Now to find the sum is equal to n by 2 into first term plus last term. Here n is 29, first term is 303 and last term is 499. So we can write it as 29 by 2 into 303 plus 499. Now 303 plus 499 is 802. So it can be written as 29 by 2 into 802. 401 2s are 802. Therefore, we can write it as 29 into 401, and that is equal to 11,629. That is sum of natural numbers between 300 and 500 that leave remainder 2 on division by 7 is 11,629. Now we have to find sum of natural numbers between 300 and 500 that leave remainder 3 on division by 7. The sequence of numbers between 300 and 500 which leave remainder 2 on division by 7 is 303, 310, 317, etc. 499. To get the remainder 3, we have to add 1 to each term. So the sequence of numbers that leave remainder 3 on division by 7 is 304, 311, 318, etc. 493. 500 is not a term of this sequence since it is not between 300 and 500. Now look at the sequence. Each term is obtained by adding 1 to the first sequence. So to find the sum, take the sum of the first sequence, that is 11,629, and each term is obtained by adding 1 to the first sequence, and since there are 29 terms, we have to add 29 to it. Now 500 is not a term of this sequence, so let us subtract 500. Now 11,629 plus 29 is 11,658. From that we have to subtract 500, and that is equal to 11,158. We can do it in the usual way also. We have got that the first term is 304 because the first term when the remainder is 2 is 303. So the first term when the remainder is 3 is 304. And we have seen that the last term is 493 because 500 is not a term of the sequence. And since there are 29 terms in the previous sequence, and since 500 is not a term of this sequence, there are only 28 terms. Now to find the sum, n by 2 into first term plus last term. Here n is 28, first term is 304 and last term is 493. So it can be written as 28 by 2 into 304 plus 493. Now 28 by 4 is 14. 304 plus 493 is 797. So that's equal to 14 into 797, and that is equal to 11,158. 29th problem. Read the following mathematical concept and answer the questions. You have learned that the sum of two even numbers is even and the sum of two odd numbers is also even. But what about the sum of three odd numbers? Like this, the product of two even numbers will be even and the product of two odd numbers is odd. If so, the power of any even number also should be even number. That is 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, etc. are even numbers. Like this, 3 raised to 2, 3 raised to 3, 3 raised to 4, 3 raised to 5, etc. are odd numbers. Odd numbers are numbers which leave remainder 1 on division by 2. So the powers of all those numbers also leave remainder 1 on division by 2. Do this property hold for numbers which leave remainder 1 on division by 3? Think. What is the remainder when 2 raised to 17 is divided by 2? Which of the following number is even? 5 raised to 3 into 3 raised to 5, 5 raised to 4 into 3 raised to 4, 5 raised to 3 plus 3 raised to 5 plus 5 raised to 3, 5 raised to 3 plus 3 raised to 5 plus 5 raised to 3 plus 3 raised to 4. Write whether the following numbers are even or not. The sum of first 100 natural numbers, the product of first 100 natural numbers. What is the remainder when 4 raised to 100 is divided by 3? Write an arithmetic sequence which contain all the powers of its tens. First question, what is the remainder when 2 raised to 17 is divided by 2? Any power of an even number is again an even number. Therefore, 2 raised to 17 is also an even number. When it is divided by 2, the remainder is 0. Second question, which of the following number is even? The product of two odd numbers is an odd number, and the power of any odd number is again an odd number. Therefore, 5 raised to 3 into 3 raised to 5 is odd. Similarly, 5 raised to 4 into 3 raised to 4 is also odd. Now, sum of 3 odd numbers is odd. Therefore, 5 raised to 3 plus 3 raised to 5 plus 5 raised to 3 is also odd. Now, sum of 4 odd numbers is even. Therefore, 5 raised to 3 plus 3 raised to 5 plus 5 raised to 3 plus 3 raised to 4 is an even number. Third question, write whether the following numbers are even or not. First one, the sum of first 100 natural numbers. Sum of first 100 natural numbers is 100 into 101 by 2, or that is equal to 50 into 101. When a number is multiplied by an even number, that is even. So 50 into 101 is even. Second part, the product of first 100 natural numbers. Whenever we multiply a number by an even number, that is also even. So the product of 100 natural numbers means there are a lot of even numbers. So definitely the product is an even number. Next problem, what is the remainder when 4 raised to 100 is divided by 3? When 4 is divided by 3, the remainder is 1. Therefore, any power of 4 gives a remainder 1 on division by 3. Therefore, 4 raised to 100 gives a remainder 1 on division by 3. And the last part, write an arithmetic sequence which contains all the powers of its tens. Let us consider the sequence of natural numbers. Any power of a natural number is again a natural number. Therefore, it is a sequence which contains all the powers of its tens. Now let us consider the sequence of odd numbers. Any power of an odd number is again an odd number. So, the sequence of odd numbers contain all the powers of its tens. Similarly, if you take a sequence of even numbers, we can see that the powers of any even number is again an even number. Therefore, the sequence of even numbers contain all the powers of its tens.